Hi and welcome to a global storm update number 3. Let's just get right on down to it. One of the things we were looking at in the previous update was the possibility of more thunderstorms and heavy rain moving into the western end of the Hawaiian island chains. And if you look at the satellite image, you can see this actually occurring. And this led to a series of flash flood warnings for the island of Kauai. But as it looked like in the previous outlook, it only did affect the western end of the chain mainly. I caught this snapshot of the weather radar derived rainfall over Kauai on the 1st of November, and there appears to have been, according to this, over 10 inches and in some spots 15 inches of rain right in the mountains. And actually, if you see this little white spot, it looks like it's pretty much directly over Mount Waialeale, which is a known rainfall hotspot of the world. We were also watching for a development in the South China Sea of some kind of tropical cyclone, and that has now occurred and can be seen. And actually at the moment it is now overland over Vietnam. Typhoon Damrey made landfall as a Category 2 typhoon and has brought a bunch of extremely heavy rain and strong winds into central Vietnam. On the 2nd of November, Typhoon Damrey was in the South China Sea progressing westward towards Vietnam, and it gradually intensified as it headed towards the coast, eventually making landfall as a Category 2 storm before weakening and dissipating as it's now heading inland but still dumping a huge amount of rain. There have been more intense thunderstorms over southern, south central, eastern South America during the period, and also over Central Africa, and of particular note is southeastern India and into Sri Lanka, where there have been some very damaging floods in Chennai. Moving over to India, you can see calm conditions with little rainfall in the north, which have led to some problems. In North India, they're having their seasonal crop burns, leading to very bad levels of pollution building up over the last several days in the north. As you can see, it's gotten so bad that you cannot even see the ground through the haze, and it's all getting jammed up against the Himalayan mountain range, unable to escape to the north and the clear Tibetan plateau. Let's take a quick look at something interesting that happened in the Middle East over the period. Going quite a way back in time, this is the 26th of October, and we can see our low pressure system that we were watching in earlier outlooks bringing a lot of thunderstorm activity to the eastern Mediterranean. The disturbance or associated winds with it progressed towards the east and into the Middle East, and at this point, which is the 28th of October, strong winds begin to pick up over the Arabian Peninsula, sucking air northward. This is what the situation looked like on the 28th of October. You can just make out a swirl of low pressure in the eastern Mediterranean, but if we go forward a day, the disturbance moves into the Middle East, and in those strong southerly winds we saw, you can see a huge mass of dust pick up over northern Saudi Arabia and into Iraq. And this actually seems to have spread up and over the southern Caspian Sea over there. By the next day, the dust was still there and concentrated over Iraq, and then gradually progressed and dispersed eastward. Continuing on this strange and dusty tangent, let's take a look at northern Africa, where there are these dry lake beds that actually provide dust that spreads all the way to the Amazon. So this is a view of the surface winds over northern Africa and covering the Saharan region, and you can see these strong winds coming down and two bands of strong winds. Now there seems to be a region of calmer winds in between these two regions of strong winds, and it turns out that that's actually due to a significant mountain range known as the Tibesti Mountains. This is a relief map of northern Africa, and if we zoom in to Chad, we'll see the Tibesti Mountains in the north of the country over here, and the winds are coming down and getting funneled on both sides of the range, sort of getting pushed around the sides, and there's Lake Chad down there. So here is our view of North Africa, and if we zoom in towards Chad, we'll see this dust storm blowing off these dry river beds here, zooming off, and then the mountains of the Tibesti mountain range are over here. The wind's getting funneled around on both sides. Down here is actually Lake Chad, or what's left of it. The highest mountain in the Tibesti mountains is actually visible on the southern flank of the range, with the winds blowing around the side. That mountain is Kusi at a height of 3,415 meters, looking like a mini Olympus Mons. This is what Kusi actually looks like. There's more information and interesting pictures on the Tibesti Mountains and Kusi on this Forbidden Sahara website. So moving on to our forecast, we're looking at the 10-day precipitation rainfall predictions from the Global Forecasting System model. The dates are up in the top right as usual, and I'll just quickly label on the ITCZ, the Intertropical Convergence Zone band of heavy rain in the tropics. At the beginning of the period, you can see Typhoon Damrey dissipating over the peninsula, and then there is further signs of some kind of low pressure development in the Bay of Bengal. Now, we were watching the Bay of Bengal in the previous outlook, and it was in this time period where there were signs of some kind of development there. So I'm going to look a little bit more at this and look at some other model predictions. So taking a more detailed look at the Global Forecasting System model simulation, we'll see the area of low pressure gradually moving into the Bay of Bengal associated with Typhoon Damrey, and then it's merging in with a more general low pressure system that deepens and then moves up and into the Bangladesh and Myanmar area. Now, this looks pretty awful in this simulation, but let's take a look at another model simulation. This is from the well-respected European Centre for Medium Range Weather Forecasting's model, and you'll see the low pressure associated with Damrey moving and then dissipating, and the disturbance moving into the Bay of Bengal. But unlike the GFS, the development of this low pressure system is less pronounced or less rapid. However, at this time, the 14th of November, there are some signs of development. So it's definitely not looking like the GFS, but there is still this area of low pressure. So the Bay of Bengal is definitely a place to be watching out. These are plots which are experimental probability plots of there being a tropical cyclone in a particular region. And if we look at the top plot, I'll advance forward through the days. It starts on the 4th of November. This is the 5th, 6th, 7th, 8th, 9th. And on the 9th we see very high probabilities of tropical cyclone in the Bay of Bengal. Continuing onwards, probabilities shifting more into the Arabian Sea, then back into the Bay of Bengal on the 13th of November, and 14th, 15th, 16th, and kind of off in, and then it goes down a bit. So these are indicating conditions favorable for some kind of genesis over these particular time periods. The GFS is also indicating the possibility of another tropical cyclone developing and passing over the Philippines and then dissipating. I'm not sure. Let's see if that actually occurs in any of the other models. If this does develop, it will have the name of Kui. This is a more detailed view of the GFS prediction, showing the low pressure system bringing a lot of rain into the Philippines on the 10th of November and then progressing into the South China Sea and deepening. However, the European Centre model fails to produce a significant system, the low pressure system seen there on November 8th, some kind of disturbance anyway, and then the low in the South China Sea, but not deepening significantly. Okay, that's enough dust and tropical cyclones. Let's move over, have a look at Europe before wrapping this up. A low pressure system moved into the Iberian Peninsula, Spain and Portugal, and brought a bunch of heavy rain, which is great news for the area that has been very dry over the last several months. And that low pressure is actually heading into the Mediterranean and looks to be quite an intense event in terms of thunderstorm activity in South France and then moving into the Alps. So we're going to actually look a little bit more about that particular event. If we look at the current lightning activity, we can see that things are ticking away over Catalonia and Spain, with a quite active thunderstorm heading off into the Mediterranean and some popping up in southern France associated with this low pressure. The low is down here, you can see it centered over southern France and bringing heavy rain into South France and the western flanks of the Alps on the 5th of November, tomorrow. And then as we progress forward, we begin to see some blues, dark blues, appearing over the higher mountains of the Alps, indicating heavy snowfall. And progressing through and onwards, the low seems to move fairly slowly and stay around northern Italy, and the areas of blue are now expanded on the northern side of the storm, where the winds are more out of the east-northeast, colder direction, and the snow level will then be dropping, but the snow totals still being quite high in these dark blues. So quite a heavy dump of snow for the Alps, it looks like, and particularly at higher elevations and then dropping. We can also look at the total accumulated rainfall and snowfall over the simulation period, and as we progress forward from the 5th of November, we can see the rain and precipitation increasing over the alpine regions as the storm system moves through and stagnates over the region. Now the values of pink and purple are above 45 millimeters to 100, and some of these are up to 100 millimeters of rain. So heavy rain, probably mainly over the northern Italian regions by the looks of things. And bear in mind that even if the rain over the higher mountains is of the order 50 millimeters, in order to get the snowfall depth, a rough calculation is to multiply it by 10, so that would be half a meter of snow. So we may be looking at some high localized or widespread actually snowfalls on the higher elevations. Okay, that's all I've got for the moment. Let me know one of the many things that I've missed, and catch you in the next one.